Hi, we are going to look at these identities now. First one is in front of you. All I want you to do is, if you think that you can do this or you want to try it, you can pause the video and you can try proving left hand side equal to right hand side. Otherwise, after that you can check your work. Right. Okay, what we do in this case is, if I pick left hand side, we said that you should always pick a side which has got more stuff on the side. Okay, it's very difficult to prove sec theta equals all that, but this side has got more information in, so I would always make a start from this side, right? So there's nothing I can do about cos at the moment. Okay, so I will leave that as it is. Now sine theta is left as it is, and I know that tan theta is equal to sine theta over cos theta. Right? Now I know that sine theta times sine theta will make sine squared theta. So I've got sine squared theta over cos of theta, and I've already got cos theta here. Now to make denominators equal, the denominator of that is just 1. To make denominators equal, I got to times that fraction, all of it, top and bottom, by cos of theta. So that makes it cos squared theta over cos theta plus sine squared theta over cos of theta. Right? Let's because denominators are same, let's write it down as a single fraction. So cos squared theta plus sine squared theta over cos of theta. Now you probably have noticed that the top is cos squared theta plus sine squared theta, which is actually the same as sine squared theta plus cos squared theta. So that is equivalent to 1. Okay, so I've got 1 over cos theta. Now 1 over cos theta is actually reciprocal of sec theta, so we can write it down as sec theta. Okay, and that's what we needed to prove. Okay, so we call it with three of these lines, which mean, and this is an identity sign, right? So that is your right hand side. Okay, and that's what we do in identities, right? Let's move on to next question. Now if you notice, if you look at this one, you've got cot of theta plus tan theta, which should be equal to cosec theta and sec theta. Once again, if you want to try this, you can pause the video and you can try doing this work, and you can check yours with mine. I know that cot of theta is actually cos theta over sine theta. I didn't tell you that I'm making a start from left hand side, so I must write down left hand side. Cos of theta over sine of theta, and tan theta is sine theta over cos theta. Denominators are different, so to make a common denominator, I should multiply first fraction by cos of theta and second fraction by sine of theta. Now when I multiply first fraction by cos of theta, I get cos squared theta over sine theta cos theta. And when I times second fraction by sine of theta, I get sine squared theta over sine theta cos theta. Right? Now because denominators are equal, I can write it down as a single fraction, okay, which is sine theta cos theta, but because denominators are same, I can put them down together. So it's cos squared theta plus sine squared theta. We know that sine squared theta plus cos squared theta makes 1, so my numerator is 1 and denominator is sine theta and cos theta as a product, right? Now that's sine theta and cos theta. Now this is 1 over sine theta cos theta. Now that's a reciprocal of 1 over sine theta and 1 over cos theta. Now 1 over sine theta we know that is equal to cosec theta. and 1 over cos theta is sec theta. Okay, and that actually is your right hand side, isn't it? Okay, so that's what we're supposed to prove, right? Okay, let's try another one. In this case we need to prove left hand side equal to right hand side. Once again I've got double bracket on this side, so I mean I should start from left hand side. Okay, I can see bracket here. There's nothing I can do in this brackets, and there's nothing in there in this one. I mean, so what I should do is I should start multiplying the contents of first bracket by the second. Okay, so when I times 1 by 1 I get 1, and when I times 1 by sec x I get sec x, so 1 sec x. When I multiply minus cos of x by 1 I get minus cos of x, and when I times minus cos of x by sec x I get minus cos x sec x. Now we know that sec x is sec of x is 1 over cos of x. We know that, don't we? So if I sub that here, what would I get then? 1 plus sec x minus cos x minus, that will be cos x times 1 over cos x. That cancels out with that, so I get 1 plus, let me call sec x as 1 over cos x minus cos x, and that is minus 1 now. Now 1 and minus 1 cancel out, so I'm left with 1 over cos x minus cos x. So 1 over cos x minus cos x. Now that cos x has got a denominator of 1. To make a common denominator I should multiply both of them by cos of x. So that makes it 1 over cos x minus cos squared x over cos x, right? Cos x, okay. Because denominators are same, so I can write it down as single denominator, which is cos of x, and top is 1 minus cos squared x. Now 1 minus cos squared x is equal to sine squared x, because we know that sine squared x plus cos squared x is equal to 1, right? And over cos x, right? What I should do here, I should split it up. I should split it up into sine x and sine x over cos of x. Now sine x over cos of x makes 10, and I've got a second sine x here, and I think that is your right hand side. If you look at it, that's your right hand side, so I should put it equal to identity, which is right hand side. Okay, this is how we prove this identity. Okay, thanks for watching.